Welcome to data analytics subjects. In this video, we are going to discuss about HDFS concepts. This HDFS stands for Hadoop Distributed File System. In the Hadoop framework, Google introduced Hadoop file system for handling storage of large volume of data. How it is handled in the Hadoop framework for processing the data. So as we all know that Hadoop is a distributed platform, distributed framework for handling distributed large scale data processing. So mainly in HDFS concepts, three components are prominent. One is blocks, another one is name node, another one is data node. First blocks in HDFS in Hadoop, a block is a minimum amount of data. So as we all know that in a distributed environment, data are shared among the nodes. So minimum amount of data it can read and write, we call it as a block. HDFS blocks are 128 MB by default, and this is configurable. That size can be changed with respect to the application requirement. Whatever the large scale data you are taking, and according to that the number of blocks you can create, and it can be configured. Whatever the files you are taking in HDFS system, it can be broken into block sized chunks, and it can be handled as a independent units in the Hadoop platform. And name node, so name node is a master node. Mainly HDFS work in the fashion of master worker pattern. This name node is the controller and manager for HDFS in the HDFS. Yes, in any Hadoop framework which you are running, one node will be the name node and other nodes will be the data node. So those data nodes, data has to be allocated, task has to be monitored, whether the task has been completed. All these are controlled and managed by your name node. File location, sharing data, metadata handling, and accessing the data in the storage. All these are handled by the name node. Data node is storing and retrieving blocks, is the job of data node, and also reporting every time to the name node about the blocks, what they are storing, what they are processing, and whether it is block is created, deleted. All those data related activities are performed in the data node. Many of the nodes are data node, and one node will act as a name node. And this HDFS Hadoop model can be installed in any system with the following models like standalone or local model, pseudo distributed model, or fully distributed model. Standalone or local model, you are configuring your HDFS in a Hadoop in a single machine, and you are making that machine as a host, and as well as the uh, application deployment machine. Pseudo distribution model, you can create distributed simulation environment like virtual machines, but not really the machines are distributed. Fully distributed model, in real time all the machines are fully distributed and across the places it has been configured. So fully it is distributed, it is not virtual, or it is not limited to any task. So we can create a really distributed Hadoop HDFS environment using fully distributed model. So key points in standalone model: one single machine, zero no daemons are running. Everything runs in single Java virtual machine, standard OS storage, and good for development, and just with small data only. Pseudo distributed single machine, but cluster is simulated. Daemons in separate JVMs in single node, good for development and debugging. Fully distributed model run Hadoop on cluster of machines. dimension and production environment. It is good for staging and production. So these are all the concepts about various models and how HDFS is installed in various machines using this model. Thank you.